tall have an average of 184 centimeters, which doesn't mean much to most of us because we don't think in centimeters, but they have a standard deviation of 8. So what percentage of Dutch men is at least 100 or 200 centimeters tall? Well, that's taller than average, right? Less than, well, it's about 2 standard deviations above average if you think about it. So let's look at this. Okay, if their average is 184, and if I want to say, well, 1 standard deviation above that is 192, and another standard deviation above that is 200. Well, wait a second. I can use the empirical rule to answer this. At least 200 centimeters tall, that means it's that tall or taller. So we're only looking for this little zone here. Well, that's only 2.5% of the entire population is more than 2 standard deviations above average. Okay? You go down to the left side a little bit, you're down to 176. Well, that's exactly what we're asking here in Part B. That's 1 standard deviation below and 1 standard deviation above. We should be able to get that because that is within 1 standard deviation. Well, that's 68% of the data, according to the empirical rule. Okay? What percentage of Dutch men is shorter than 160? Well, you go another standard deviation, another 2 standard deviations below. That's getting downright crazy. So you're 1, 2, and 3 standard deviations below average. There you're at 160. What are the chances you're below that? Well, less often referred to as the 3rd standard deviation. 68, 95, and 99.7. That's how much falls within 3 standard deviations of normally distributed Dutch men. Okay? So that means only half of 0.3%. So 0.15%, less than 1%, are shorter than 160 centimeters tall. Okay? You take half of what's left from the 99.7 that's within. You got 0.3% that's located on either side, really tall or really short. That's half of 0.3. 0.3 divided by 2 is equal to that. There you have it. And these are all percents. So for comparison, the average height of American is 176 with a standard deviation of 7 centimeters, which is most unusual. A Dutch man is 211 centimeters tall, or an American who is 200 centimeters tall. Well, we'll have to do the z-score again. Okay? So Dutch man, 211 minus 184 divided by 8. So you got 211 divided by 184 minus 184 divided by 8. That's equal to 3.375. It's the interest rate I got on my house. Just FYI. The male, who's 200 centimeters tall, that's 200 minus 176 divided by 7. So 200 minus 176 is equal to 224. Divide that by 7, and that's equal to 3.429. Okay. This person is more standard deviations above average than this person is. So the American is taller because he's more standard. The explanation, you can have numbers, but you need to be able to explain them to get full credit in my class. So more standard deviations above average, the American, than the Dutch men. Okay? All right. And lastly, I guess we'll just kind of crank this out right now. In 1995, the Educational Testing Service, the ETS, adjusted scores SATs due to human error in the grading system. Before this adjusted the score, the mean was 450 with a standard deviation of 100. How would adding 50 points to each score affect the mean? Well, the mean would be up to 500, wouldn't it? How would it affect the standard deviation? The standard deviation would still be at 100. Whoops. No effect to the standard deviation, because if we added the 50 points, it would affect the mean but not the standard deviation. If we create a dot plot of test takers, original scores, and the other dot plot of test scores, adding 50 points to each, describe the differences between the dot plot. Use terms of center, spread in your description. Measures of center, which would be the mean, median, and mode would change. That's a D. Would increase by 50. Okay. Measures of spread, which are the standard deviation and the range, would not change. All right. Thank you very much.